Hi everyone. Thank you for coming here this evening. I'm actually surprised to see so many people at 5 in the evening last session. But yeah, thank you for coming here. Our talk is going to be about Rails services in the walled garden. There are two of us presenting here. For this is Niranjan, my colleague. He's Akamiya on GitHub and Niranjan P on Twitter. And this is me, Sidu. I'm Kairan on GitHub and Ponnappa on Twitter. We both work at C42 Engineering. This is a small Ruby consultancy based out of Bangalore in India. And let's get started with a little bit of background about this talk, just to set some context. So this talk is based primarily off our work building a suite of 9+ services at a fairly large business. These services were a bunch of Rails applications that today automate entire data centers. This is one of the largest hosting companies in the world. So it's probably one of the biggest deployments of Rails services that I've had a chance to work on. We've built a bunch of other stuff, but this was the most interesting because we were replacing a monolithic legacy application that was causing a lot of pain to the business and was pretty old and was mission critical. Since then, we've done other stuff, but a lot of API work, but I don't think any of them have come close to the scale and complexity of that particular project. But we've done a bunch of stuff with 2 APIs, 3 APIs in that scale. So almost without intending to, we became something of a little bit of a focus group for APIs back home. So this talk is about Rails and service-oriented architectures and in the walled garden. So let me talk about these things in bits and pieces as to break them down and talk about why they're relevant. But I think the single most important thing here is why do we say walled garden? Now, by walled garden, I mean services that run within a business, which are not being consumed by people outside the business. This allows us to have a certain amount of leeway in how we structure and write these APIs so that we save on multiple things. We save primarily on effort and cost. We don't have to go the full REST, HateOS, full-blown consumer API way because we have far more control. So these are the assumptions we make, and there is a certain structure to this talk as well. This talk is going to be structured around the problems and the pain points we ran into when building APIs inside the walled garden. So I think the first question is, why SOA?
Okay, so let's just quickly summarize the advantages of using SOA versus building a monolithic application. First of all, it allows us to break our application as per multiple business verticals we have in our organization, where individual service provides an API to consume by that vertical, whereas it also provides integration points for other services to provide organization-wide workflows. Every application, rather every service is a self-contained, which means that whatever development I'm doing in that service doesn't cause ripple effects to all other services across the board, as long as my API remains constant. The way it helps is, whenever we are building a complex workflow for a particular vertical, we don't have to worry about all other business domains which we don't understand or don't care about. Essentially, it means that we can independently evolve a particular vertical while allowing other verticals to integrate with it. It also allows us to independently deploy a particular service. Say, for example, if I'm working on one particular business vertical and I'm done in 2 weeks, but there is this other particular service which is being developed, and if it takes 4 weeks, I need not wait for 4 weeks before I can deploy my service. I just have to make sure that I'm not breaking the API, and I can push things to production as soon as I'm done with them. Now, it also allows us to monitor what services are being hit more frequently and scale those services instead of scaling the entire suite of services. They are easy to maintain. If code base is small, if code base is independent, the code quality is generally higher. The bigger your code base gets, messier it becomes, and more broken windows it will have. So definitely it helps. We all know that smaller teams working on individual code bases is much better than one massive team of, say, 8, 10, 15, or 20 people working on a shared code base. So these are all advantages, and list continues. But there are some disadvantages of building service-oriented architecture. So what are these disadvantages? First and foremost, services like to talk a lot. They talk to each other, and this essentially can lead to performance bottleneck because every service call you're making comes up with its own HTTP and framework overheads, which we cannot avoid. We have to provide some sort of transparent authorization and authentication across all services. We cannot just go with authorization for service because we want to implement workflows which span multiple services. It is difficult to implement database transactions, like ACID transactions, across distributed databases. When it comes to distributed services, it's even bigger problem because we have to manage it over HTTP. So then anytime we are talking about building services, we always talk about how we are going to version the API and how to make sure that my APIs are backward compatible. If there are old clients, they should be able to talk to new services. And last but not least, continuous integration, like making sure that there is a continuous integration build running across multiple services, which does actual integration testing by spinning up all the services and making calls which span all those workflows is difficult.
Okay, so we've gone through some sort of a justification for why service-oriented architecture is important, but why is Rails important in this context? Well, frankly, it's the most awesome thing I've seen to create APIs. It's ridiculously easy. It gives you powerful routing. I'm sorry, I was about to say routing, I'm Indian. But powerful routing, which means that it is probably the most convenient thing that I've seen to map HTTP requests to a block of code, which then creates a resource for you. It gives you, again, what's probably among the best MIME-type negotiation frameworks out of the box. Like if you try to do this with something else, it's not that trivial. So dealing with different kinds of representations, content types is really easy with Rails. You have less boilerplate code. I mean, there is still some, but if you've ever seen a Spring code base, believe me, Rails is so much better. And then there's the bottom line, which is that Ruby is nice. I mean, given a choice between writing code in Ruby and writing code in Java, there's no reason why I wouldn't pick Ruby. But this begs the question, what about the other popular frameworks? What about Sinatra? What about Padrino? What about other similar frameworks? Now, this talk doesn't discount those. Much of what we're going to cover is relevant to those frameworks as well. It's just that Rails is extremely popular and gives you a lot of the things that you need out of the box. So we're going to talk about Rails. But most of what we're covering is just as relevant for Sinatra and friends as it is for Rails. And walled gardens. Now, let's go a little further into what I mean by walled gardens beyond my original explanation. It's the first premise that I'm making here is that being inside a walled garden is easier. You don't have thousands of consumers. You don't have your APIs being consumed in unpredictable ways. You have full visibility into the evolution of clients that consume your APIs because this is all within your organization. It's easier to form a roadmap. Now, what this means is that you can avoid certain costs that you otherwise have no choice but to incur with public general consumers. I am also going to be using certain REST-related terminology here, which if it's unfamiliar for whatever reason, we can talk about it in the QA. But I'm just going to make a certain assumption here that people are familiar with it in passing. So one thing is that if you're going to try to build a full HTOS architecture, it's extremely expensive. It's expensive in terms of implementation effort. It's expensive in terms of performance. And quite frankly, I haven't seen a full Richardson Maturity Model Level 3 API in the wild yet. I'd love to see one. If anybody's run into one and can point me at one, that would be awesome, but I haven't seen one. I've tried to build one. It's pretty hard. So there is no reason to build a full HTOS architecture within the walled garden. HTOS exists to solve a lot of issues that crop up when consumers are using your APIs. Rails does Richardson Maturity Model Level 2, 2.5, somewhere between 2 and 3, pretty much out of the box. You can get 2 just like that. With a little bit of effort, you get a little beyond that. And this is free. Now, Richardson Maturity Model, for those of you that are not familiar, is a model which tells you the levels of restfulness of APIs, and the highest level is a 3. So Rails gets pretty close for free out of the box. And while we're talking about this, let me quickly call out this one glaringly obvious thing, which is that Rails is not REST. There is, like RESTful routes, is marketing. Like having RESTful routes doesn't mean your API is RESTful in the least. Using Rails, again, doesn't mean that your API is RESTful. It does take a certain amount of work. Now, as I mentioned earlier, this talk is broken down into a series of areas of interest that we found were bottlenecks while developing services. And that's what we're going to structure this talk around going forward. This was the background, a little bit of context, and now we're going to start digging into problems and solutions. So first off, we have?
Yeah. So first and foremost thing, let's talk about authentication. Whenever we're building any services, we do want to guard those services, make sure that only certain set of people are able to consume those APIs or whatever. Now, interesting thing is, when we are building authentication across services, we need to make sure that we are implementing it in such a way that once I log into one service, I can actually go through a workflow which spans multiple services without re-authenticating against a server or different services. Now, when we are building RESTful services, obviously these whatever authentication mechanism we come up with has to be stateless, which means that I cannot use cookies, which Rails generally uses for managing authentication. Now, the quickest, simplest, and cheapest way to get this authentication done is just put a firewall in front of all your APIs, get a range of IPs which can access those APIs, and you're kind of done. Make sure that every consumer is sitting within those IP ranges, and no one else will be able to access those APIs anymore. And it will work in a small scenario, but as your services grow more and more complex, you want a better solution. What you want is essentially some sort of centralized authentication system so that user can actually authenticate against that central authentication system and then start using APIs which are behind authentication firewall. Now, there are multiple services which we are already consuming which are doing this. Say, for example, Facebook does it, GitHub does it, Twitter does it. They all allow us to actually authenticate against them as a service, and we can simply use them. But as we are inside a walled garden, we might not have access to those services, or we might not need those services for authentication at all. So what do? We can simply create our own authentication provider. Like OAuth 2, there are multiple OAuth 2 providers out there, and we can just use one of them, tweak them as per our necessity. Now, why OAuth 2? OAuth 2 is pretty much becoming industry standard nowadays. It gives you a very definite guidelines in terms of what you need to do to actually achieve authentication across services. It's very simple to implement. Rather, if you have a good net HTTP client, you can implement an OAuth 2 client in a matter of, say, 30 minutes. There is a simple sample client available in one of our open source projects. You can take a look at that if you want to. But what happens if you are using active resource as your client? That's an interesting question, because active resource by default doesn't give you any access to response headers or request headers, and OAuth 2 primarily works on information passed through headers. So essentially, if we are not willing to monkey patch the active resource is out of the door. So we have to consider two things. Either we use active resource, open it up, make sure that we have access to response headers, and we can set auth headers for every outbound request, or we can simply reconsider the active resource itself. Now, while we are building all these services inside a walled garden, we might have some kind of external client. The client is not external as in developed by someone else, but developed by us, but accessed by external user. Now, if we are already an OAuth 2 provider, we can essentially use any of the external OAuth 2 providers and just get the authentication done. Like we can use Google OAuth, or we can use Facebook OAuth, and let user authenticate against those and access our consumers.
Okay, so next up, right after authentication, the next thing with an A, authorization. This is pretty much a done deal in Rails if you're looking at standalone apps, right? User roles. We have dozens of gems that do this and do it pretty well. Now, the hard thing is when roles have to happen over HTTP. That is, authorization at a service level. Now, there are several ways to look at this problem. You could potentially look at having centralized rules. That is, you have an authorization service which contains all the roles, the users, and the rules that apply to them. Now, the problem with this is it gets messy and fragmented. The whole point of having services so that services can evolve independently. If you impose rules on them from the outside, you're already constraining their ability to evolve independently. So what's the solution to this? What we recommend and what we've seen that works for us to have centralized roles but federated rules. Just have a very clear set of responsibilities for your authorization service, which is it simply maps users to roles and nothing more, right? Beyond that, what those roles mean for particular resources and particular services is left to those services. Then we have the next thing, which is?
Yeah, so while talking about problems with service-oriented architecture, I mentioned that there is chattiness between services. Now, let's just take an example. Assume we have this one client and two services which are sitting, which we are developing, and there is one central auth server. Now, client makes a request saying that, hey, I want this information. The first thing service has to do is validate with auth server whether requesting user is valid or not. Once it has gotten confirmation from auth server that, yes, go ahead and process this request, to complete the workflow, service 1 internally calls service 2, passing the user information. Now, service 2 cannot depend on the fact that service 1 has authenticated the user, so it has to authenticate it again. Once it gets the go-ahead from auth server, it will actually generate the response, send it back, and then service 1 will process it further and send it back to the client. So it's going to grow. The more services you add to this workflow, your HTTP graph is going to shoot like crazy. And there is no really a silver bullet to solve this problem, because if you are building independent services which are talking over HTTP, they are going to talk. But there are certain things which can do to minimize the problem which we'll face with chattiness of the application. First and foremost, you want to make sure that your requests are fast. So early in a project, you want to set up some kind of a performance build which makes sure that all the requests are satisfying certain criteria. Say for example, take every GET request should be more or less equal to 40 milliseconds. It shouldn't go beyond that. Once this particular performance build in place, you should monitor the trends, while your services are growing and your applications are becoming more and more complex, how these response times are changing and what kind of tweaking you need to make sure that those response times are brought down again. Now, most of the requests you are making across your services are going to return smaller payloads. And you need to make sure that you are optimizing your app servers, your web servers to handle these smaller payloads. Say, for example, Apache versus Nginx. Which one do you want to choose as your web server? You need to consider that. And obviously, you want to keep the payloads small, because if you try to return, say, 50 MB of XML, it is going to slow your entire network down and potentially get down the performance of entire service suite. Now, while that is possible, another thing you can start introducing is caching. HTTP 3.04, not modified, is the best thing you can do. You can implement server-side caching, you can implement client-side caching. Rails comes with fragment caching, action caching. If you have resources which need authorization and authentication, you can just action cache them, and it will take care of before filters before actually returning a response. If you have some resources which don't need authentication, you can just simply page cache them, and your web server will take care of directly serving them out of your public directory. Another thing you can do is you can start using e-tags. But the catch there is, to use e-tags, you want a client which can support caching. So essentially, client sends a e-tag in a request, and server responds saying that, hey, yeah, resource not modified, just load it from your cache. And catch here is, again, if you're using active resource as your client, it neither supports caching at the client side, nor does it allow you to open the request header to put e-tag in every request. So what can you do? So there is this open source library which you can use, which actually supports client-side caching, and just if you slap on top of it active model, you can build your own client instead of active resource and use that instead of using active resource. Only thing is, obviously, active resource comes with this whole plethora of functionality. You might not have all of them, but you can introduce them as and when you need them. Now, we have covered the client-side caching and server-side caching, but there is this whole caching which happens in the middle over internet. You might not need that if you are actually developing a set of services which are local to an installation. But if your services are actually spanning across the globe, you might want to consider some kind of caching in the middle. Say, for example, you might want to look at Varnish or Squid to cache your resources in between. Now, whenever we talk about caching, you have to also take care of when and how you expire the cache. Now, server-side caching, client-side caching is still, there are like solutions to expire those caches, but what you might want to look at is if you are actually putting some cache in middle, how to expire Squid caches or Varnish caches, because otherwise that's going to come and hit you. So, yeah, that's about caching.
Okay, so next up is something that doesn't usually get a lot of attention when we're talking about services, which is pagination. Now, let me just just jump in with an example, and I hope that will illustrate. The default index action in Rails, I'm sure you're all familiar with, is basically active record base all. This is what the template generates. This means that when you're doing a search or looking something up for an API, it's going to return everything the database has. Now, if you have 50K records, that's pretty much what you get. So pagination is very important, and we do have a fairly nice solution for it already, which is will paginate. Now, will paginate runs off 3 pieces of pagination metadata, which is which page are we on, how many records do we have in that page, and how many records do we have in total. Now, these 3 pieces of metadata, we need to start mapping them to HTTP requests so that we can start paginating over APIs. So there are a few possible places or ways in which we can tackle this problem. The first one right off is HTTP headers. We can put these 3 pieces of metadata into the headers. It's a little aesthetically displeasing because this is not really what headers were meant for. And it isn't really modeling the resource, because the resource that you're modeling is really a collection. So these are intrinsic parts of the resource itself. They're not metadata sitting in the headers. You could put them into the XML tag attributes. So the root tags carry these 3 attributes, page per page and total count. And that's another way to look at it. Now, again, this is somewhat displeasing because it isn't modeling the resource, same as before. Second, it depends on the fact that you can have attributes in the first place. What if you're using JSON? And then, of course, there is what I was talking about, which is to actually model this as it should be modeled, which is that you have a resource that is a collection. If you're going full HateOS, you basically have these 3 attributes and then a bunch of URIs. But again, we come back to active resource, which does not do this. So if you're using active resource, I mean, stepping back, if you're using some other client, it's cool. I would probably go with collection resources. But if you're using active resources, active resource, what you want is something that's a combination of active resource and will paginate. Just like in normal Rails app, we have active record and will paginate. So what we did is pick option number 2, which is XML tag attributes, because we found that this was pretty easy to implement across the board. And put that together to create something called POX paginate, which you can find on GitHub. This is something that we wrote to allow active resource to transparently paginate. So something you could potentially look at as a solution. Yes. So on to the next area.
Yeah. So let's talk about slightly more complex problems which we might face while building services. And that is, now we have caching at the server side, caching at the client side, but sometimes what we want is not the cached responses, but the cached objects themselves. Now, let's take a look at this scenario. For example, we have this user management service, which actually manages multiple users under different companies. And we have this project management service, which actually manages projects for a particular user. Now, we get a new requirement saying that as an admin user, I want all projects which are for a given company. Now, there's a problem, because in normal monolithic application, wherein we have everything available in one place, we can just fire a database query and get the result out. But if you see this model, we have company information here, and we have project information in some other service. So we have to make sure that we actually somehow get that information from other service and create the join ourselves. So what we are essentially doing is we are actually making an HTTP call to an external resource to get all the user IDs belonging to a particular company, and then fire a database query to get all the projects which are in where user ID is in list of user IDs. Now, that's very trivial explanation, way to do it. The problem with that is if your user management service itself is returning you a paginated view of users, in that case, you have to fire multiple calls before you can get a whole list of users which belong to a particular company. Now, if that list of users is really large, in that case, when you're firing a database query, at that time, you'll probably hit the SQL query limit. Like, it will go beyond 4 KB, and you won't be able to fire that query at all. So how to solve this problem? One way to solve this problem is essentially services share their data with other services directly to the database. But I seriously wouldn't recommend that. What happens if service 1 starts writing into the database of service 2? Essentially, it defeats the whole purpose of going service-oriented in the first place, because now every service knows about every other service, like internals. Other way to do it, to prevent the actual data writing, we can probably give read-only connection, like create a separate database user and share it, which only has read privileges on the schema, or maybe create master-slave database configuration and create a read-only slave copy. Now, going by this approach definitely gives you some benefits that, first of all, everything is immediately consistent. So moment I update user in my user management system and update my report, which gives me all the projects in the company, that report will automatically get refreshed immediately without doing anything. It is fairly easy to implement. I just have to drop another configuration in my database.yaml, configure my active record to talk to yet another database connection, and I'm kind of done. But there are problems with this kind of approach. First of all, we are integrating different services at the database level. So essentially, we are breaking the encapsulation which otherwise service provides over its internal data, and we don't want to break the encapsulation. What if there are computed fields which are present in the external representation of a particular resource which is provided by service? Those computed fields won't be available when you are directly hitting the database. We are assuming that there is a one-to-one relationship between the resources exposed by the API and the tables in the database. That might not be true. Essentially, you're exposing internals of your one service to other service, which means that I cannot now independently evolve and modify my second service, even though I'm maintaining my APIs properly. So, case in point, my user management system is currently using MySQL as data store, and I find out that it's really becoming expensive and I want to shift to some kind of NoSQL database. Now I can no longer do it because there's some other service which directly talks to my database, and hence I'm kind of tied into that solution. So all in all, try to avoid it. It might work in certain scenarios, but stay away from it if possible. So what is the other solution to implement the same thing? Before we talk about some other solution, let's talk about another problem we have which has similar solutions.
So something that comes up pretty often in most systems is an implementation of the observer pattern. An event occurs somewhere, somebody else wants to know about it, and you want to decouple these two. So a trivial example of this in the case of services is a post-logout event, right? I have a user service, my user logs out. There are a bunch of other services that want to know about this, either to simply expire their sessions if they have one, or maybe they have some other things that trigger off that event. Now, there are a couple of ways we can do this. The most simple thing we can do is have a bunch of callback URIs, right? So my client services register with the parent service, saying that call me back at this URI when a user logs out or when any other event happens. And that's it. When the event occurs, the main service will do the callback. And as you can tell by my conversation, you have callback hell. It's really hard to explain, therefore it's probably hard to understand. Your configurations also get complex. And then with all of these callbacks, your response times, if you're doing this within the request-response cycle, tend to get really, really long. You could, of course, solve this by having async callbacks, right? Just throw background RB or something similar at it and have these callbacks run in the background. Another way to look at this is potentially introduce an MQ system, like something like RabbitMQ or something like some similar tool. This gives us a centralized bus, which is an interesting difference from the previous one. In the previous case, you had to know every single service that you were interested in and explicitly go register yourself with that. Now here, you just have a centralized bus, and then you register listeners to that, and then you get all your events coming to you right there. So you just have one authoritative source. It's async out of the box, which is an interesting difference from the previous approach, where you consciously have to make the decision to make it async. And you probably want to do some sort of convention over configuration with regards to your topics or whatever names you use for your events. But otherwise, these two approaches are broadly similar, and you can pick and choose between them. But they're interesting because they lead up to a solution to what we were talking about, that Niranjan was talking about earlier, that I let him continue with.
Yeah. So again, going back to the problem we had, and now going to the solution of that problem, which is neater than actually sharing the database across multiple services. Now, assume that we actually set up some kind of event system which triggers the event when resources are created, updated, or deleted. And my second service, which actually wants a local cache of the first service, which is actually triggering those events, can listen to those events and create resources in database. In this way, I'm not depending on the database on the database integration, but what I'm depending on is whatever events which are triggered, whatever payload is in that event, I take that payload, modify it the way I want it for my local cache, and store it so that I can actually fire the joins which we could have fired in monolithic application in this distributed services as well. But you have to keep one thing in mind, that whatever you're storing in our local database is still a cache. It's not actual connection. It doesn't have any actual connection with the resource which is sitting behind some other service. So we should treat it like a cache. We shouldn't modify it locally, because those changes are not going to get reflected anywhere else in the system, and essentially you are just like the reports you are generating are going to be bad. If we are going with evented system, which is asynchronous, another thing you need to keep in mind is whatever local cache we have might not reflect in real time the actual data which is present behind some other service. And as it is not real time, you need to pick and choose all those resources which you want to cache locally, keeping this in mind that whatever I'm getting, there might be some lag in reflection. Now, whenever we are caching anything, we have to talk about how we are going to expire cache. So obviously, if I'm listening to creation of users in user management system, I also have to listen to things like update event and delete event, and accordingly modify my local cache so that it actually reflects what is there on the server. And obviously, the server has to trigger those events with payload, which allows my consumer to modify their local caches. Yep.
So this is something that we, again, mentioned earlier, API versioning. Unfortunately, there doesn't seem to be any holy grail here. Like the pure REST guys talk about APIs that practically never need versioning. But in practice on the internet, we see URIs with V1, V2, V3, so on and so forth. Now, there are a few ways to deal with this problem inside of a walled garden, and a few guidelines. One thing is to just ensure that your resource representations remain as far as possible backward compatible, and that when you're changing them, or especially when you're removing fields from your resources, you're notifying your clients, which you can do because they're all in the same organization as you are. You may also want to consider having a front-end server which routes to different versions of the application entirely. So you actually let version 1 run for a while when version 1.1 is out there, so that clients have time, even though they're within your organization, they have time to migrate and change. And yeah, that's pretty much it. Just a little bit of common sense, a little bit of communication really within the organization can work wonders, can remove API versioning as a pain point.
Now, the transactionality of various calls we are making, specifically for those workflows which are spanning across multiple services. Even in distributed databases, it is hard to achieve. There is something called as two-phase commit, and databases actually implement two-phase commit, depending on which database you're using, to achieve transactionality across distributed databases. It is even harder when we are talking over HTTP, and honestly speaking, though we have seen one such implementation working, we haven't worked on it, and that would be talk in itself, like 40-45 minutes talk. So I'm just going to take it offline, and if anyone is interested, we can talk about it. But yeah, I'm going to keep that aside for time being.
Okay, and then we have one of the hardest things to deal with in these things, which is just the core engineering, the software engineering aspects of the whole development process. This is something that I picked up off one of my projects, which is standardize like crazy, right? Standardize everything. If you have any tooling, any libraries that are part of one service, make sure that all services use them. Versions of libraries should be the same. As far as possible, ensure that every service, every code base uses the same tools, same versions across the board. If you're doing an upgrade, calculate the cost and upgrade across the board, because engineers working on different code bases shouldn't have any surprising things to deal with or different ways of implementing the exact same things in different services. Within an organization, if you have to deal with that, it can be quite a pain. Treat shared code between services like any library. Like you may want to go as far as to spin up your own gem server, create gems that are purely local, not published out there, and have bundler use those gems. Like go that far, because this is an important aspect of standardizing shared code between all the different services. Another smell to keep an eye out for is conflation of human consumption of APIs with machine consumptions. That is, are you really producing an API or are you producing HTML? So this kind of code, I'm not sure how clear this is a smell. If you see an action that that has both format XML or format JSON or something similar with format HTML, in the same action, this is a smell, watch out for this. As far as possible, you want to try to segment your actions so that they either deal purely with machine consumable APIs or with people. The two don't fit well together. There is a mismatch there. There is a whole spectrum of separation that you can create, starting from simply saying, all right, I'm going to make sure that some controllers deal purely with APIs and some controllers purely deal with people, to all the way to the other extreme, which is to say I will build entire applications that have nothing but APIs and no HTML at all, and I will build a separate application that is for people, and that will act as a front end to this one. The new Twitter UI is probably a good example of something like this, even though it's for public consumption. Configuration management can become something of a nightmare across multiple services, so don't commit configuration into version control. Use something like Chef or Puppet to manage it. So if you're looking at multiple servers, like if you have like 10 services, you're probably looking at a minimum of 30 or 40 servers. Deal with it using Chef and Puppet. Standardize your configurations across the board. Have the same web servers, same caches, same everything. So yeah, that's pretty much our talk. That's it. And we're open for questions and answers. Yeah,
The Twilio API is not 100% ADOS, but they are actively moving towards it and want to be that way. So it is the shining example of true RESTful at a large scale, high volume.
Awesome, I'll check that out.
Yeah.
Anybody else? Any questions? Sure. We actually started off with a system that was monolithic and already handled a certain volume of transactions. So we were looking at, I don't remember, what was it, 30,000 requests per hour, something like in that range. And that was only so we were a team that was working on one service. So our service got 30,000 requests. There were other services that probably got a lot more. Sure.
Actually, I have two questions. One is, I think we mentioned that Rails, one of the reasons for choosing Rails is the content negotiation part, which, as far as I remember, is part of Correction now, right?
Yes.
Yeah.
There goes your main reason for using Rails, because especially since the last time where you said don't mix HTML and XML as separate controls, and we can just build it in Sinatra or in Pure.
Right. So that's exactly why I was saying earlier that most of what we're saying applies to everything in the Ruby ecosystem. So my example really was in contrast with not Rails versus Sinatra, but it was more Rails versus Spring or Cake PHP or Django or something like that.
The second question would be, what about timeouts and failures of specific services?
What about?
If you have timeouts from one service to another or failure 500 or something?
Sure. So we didn't really address that, but one of the things that you want to look at is, unless you have your system actually go down, you want to have that performance build monitoring your entire call graph, if that's the right phrase to use, so that at any given point in time you don't have timeouts. Now, I was on one story that looked at exactly this, where one request spanned out into about 200 requests and took about, I don't know, it was like 3 minutes or something crazy like that. And you just don't want to get there, right? The simple solution to that is don't get there. Like, track these things up front, because there is no good answer. The other thing to do is to go async, and async is a whole different ballgame. If you're looking at an async system where your request response cycle has a bunch of stuff happening in the background, that's a whole different ballgame from this. So this pretty much says that, okay, if you're going synchronous from request to response, just manage your time so that your entire request response cycle happens in the same manner. Now, we know this is possible because I think one article I read said that every Amazon page that in the store has 135 services behind it or something similar. So we know it's doable. I haven't done it for 135, I've done it for a dozen. So yeah, no good answer, just track those trends and make sure that it isn't going wild. Sure.
If you go this over again, the reasoning to go to auth, because it increases the chattiness from service to service versus doing something like SSH tunneling or keys or something like that.
Sure. I'm not sure people at the back got that. The question was what's the reasoning behind going to OAuth as opposed to something like SSH tunneling or any other solution that we could come up with? You want to take this one?
So essentially, as I said, like OAuth is pretty much standard and it's easy to implement, okay? And it gives you standard set of guidelines that, hey, put this in your HTTP headers, and you're dealing with HTTP stack. You're not going for your authentication and authorization beyond HTTP stack. So if you actually want to send a request, okay, now imagine that you have some servers deployed on EC2, some are in Rackspace Cloud. Everything is under your control, but you want to maintain them at separate places just for maintaining the redundancy and making sure nothing goes down. And everything is behind the firewall. How you're going to open SSH tunnels across different services. So there can be a bunch of such problems which will crop in. Again, do you want to have SSH access to your production box or not, is the first question.
So the other angle, the other response I would have is that, again, it comes back to standardization. Like OAuth 2 is understood, respected, and it isn't surprising. And whatever performance losses you may have using OAuth 2, clearly there are a bunch of businesses that are working despite those. So it is potentially doable. It's just a question of implementing it in the right way, and that, again, is just very, very implementation specific. It depends on your setup. So on that side, do I have a good formula to say, can you do this and make sure your OAuth 2 is going to be really fast? No, I don't. But you're just going to have to profile it and make sure that you're doing certain things right. Anybody else? Yeah, I see one hand there.
I happen to have implemented a fairly similar system at one point. I just thought I'd share another approach that we had.
Sure.
Requests issues.
Sure.
We just added a lightweight representation to all of our resources or info, and that just showed whatever the local information it had without having to make other requests. We found that 99% of the time that would eliminate the need for that. So
Right, that's pretty interesting. So you basically have a subset of information plus a pointer to whatever else somebody might need.
You get canonical location of the resources for everyone who uses the full.
Right, so somebody wants it, they go ask for it.
Exactly.
That makes a lot of sense. Okay, great. Anybody, any other questions? No? Great, awesome. So thank you, everyone. Thank you very much. Please